Okay, I keep losing my thing. Okay, guys, this is what I'm talking about for exercise 4, number 1. If you have your textbook here, can you just put 120 degree there? So a few books had it filled in already, because I think that's what makes it match the answers at the back of the book. All right, so you needed obviously this angle in order to use opposite angles of a cyclic quad in order to get Z. So if you didn't have that and you couldn't find an answer to Z, that's fine. But now if we know that it's 120, does it make sense that Z must be 60? Because the opposite angles of a cyclic quad must add up to 180, right? So if that's 120, then Z would have to be 60. But for all of the others, you could do it, all right? For every single one, it was just opposite angles of a cyclic quad every time. So just saying 180 minus the angle that was opposite to it, and then you would get that answer. But guys, you don't have to show the 180 minus part. You can just write the actual value and then your reason. Okay, then for number 2, you had to use exterior angle of a cyclic quad to get going. And then after that, you didn't have to have exactly the same reasons as mine. I just want to show you quickly. We remember that the exterior angle of a cyclic quad, so if we're doing A, oh, flip, I only found these values. I didn't realize that there were more questions. Sorry, I'll do that now. If you are finding A here, A is the exterior angle of this cyclic quad, right? Because it's a side that's been lengthened. So A is going to be equal to the opposite interior angle. So we look at the angle next to it, and then the angle opposite to that one is 101. So A is going to be 101 degrees because of exterior angle. Then to find B, if you had A, you could just use opposite angles of a cyclic quad, yes? Yeah, I think it was probably someone that did it and they just filled everything in instead of redrawing it.
No, like it was printed.
The same thing happened in the previous exercise. That's so weird. Yeah, I suppose that's a misprint. Did it have A, B, C, and then the value as well? Oh, that's frustrating. Okay, yeah, then I suppose you would just have to write the reason there. Okay, then, so B, you could use opposite angles. For C, I used exterior angle again because C is now an exterior angle of this cyclic quad. So it's going to be equal to 82, right? And then for D, I used opposite angles of cyclic quad using the value of C. I'll show you all the answers now if it wasn't printed. And then E, you could use angles on a straight line. You could use opposite angles of a cyclic quad. You could use exterior angle of a cyclic quad. All right, so there were multiple reasons that you could have used. Same for F. For F, you also could have used angles on a straight line or exterior angle, or you could have used opposite angle. Yes. Of a cyclic quad. Yes, yeah, you could. Right, so those are my answers. Just let me know if you had other reasons there that you want to check if it's fine. Okay, so that was actually 2.1. My apologies. 2.1. I'll have to do 2.2 on the back of this page. So 2.2, 2.3, 2.4, you had to use the answers that you had. Let me just quickly fill everything in here. 101, 79. Okay. So we have all those values now. 2.2, they're asking, is UY parallel to VX? So UY is this line here. VX is that line there. We can clearly see that they don't look like they're parallel, but that's not enough, all right? We have to actually have mathematical reasons. So what I would try and do immediately is I would check whether co-interior angles add up to 180, right? And do we see that they very clearly don't? 101 plus 98 is 199, right? Not 180 degrees. We know that co-interior angles, we're looking at the C shape. If they lie between parallel lines, will add up to 180. So because they don't add up to 180, they are not parallel. Okay, so let me just show you how you would write that out. So 2.2. So I would just actually show that I'm adding them together. So I would just say that angle U plus angle V is equal to 98 plus 101, which is 199, which is not equal to 180. All right, or you could write that in the next line. Therefore, UY is not parallel to VX. Okay, so you just do the parallel symbol and you draw a line through it. And the reason for that would be co-interior angles, not supplementary. Okay, you can use sup as an abbreviation. I'm sure. Yes, you could. Yeah, so there were a few options there. You could use Y and X. You could also use A and E. You could also use F and C. Right, so you could have taken any of those 4 pairs. Sorry, let's look at that. There's also a C shape there, right? If we look at that, 79 plus 82, that's also not 180. So that also would have been, if you could have shown those two. Same thing here, if we do A plus E, again, we get 199, so they're not. Or if you use angle Y plus X, that also does not equal 180 degrees, so also not parallel. Okay, next one is UV, which is this line, parallel to YX, right? UV parallel to YX. Now, if we're looking at this top, these two angles there, what is 98 plus 82? That is 180, right? And if we look at these bottom ones, the same thing happens. 101 plus 79, that's also 180 degrees. So these co-interior angles actually add up to 180 degrees. So these two lines will be parallel. Okay, I'm going to work with V and X, but you could also work with U and Y. It doesn't really matter. Okay, so that was 2.3. You would say that V plus X is equal to 101 plus 79, which is 180 degrees. Therefore, UV is parallel to YX. And now we say co-interior angles. And now you can just say supplementary. Or you can also say equal 180. And for this one, you also could have said is not equal to 180. All right, are we fine with that one? 2.4, just put the picture up again. Is UVXY a cyclic quad? Justify your answer. So UVXY, so this whole shape. So basically they're asking us if we could draw a circle going through those 4 points, right? That's another way in which they could have worded that question. Is it a cyclic quad? Justify your answer. Now guys, the first method of proving whether something is a cyclic quad or not is usually to check if the opposite angles add up to 180. So if this is the quad that we're looking at, then U and X would be opposite. Now, is 98 plus 79 equal to 180? No. All right, what about these ones? 101 plus 82, that's 183. All right, so not 180 degrees. So this is in fact not a cyclic quad. Okay, so 2.4. I'll just again say angle V plus angle Y, but you also could have said U plus X. It can be either pair of opposite angles, it doesn't matter, is equal to 101 plus 82, which is 183, which is again not equal to 180. Therefore, UVXY is not a cyclic quad. And the reason they would be converse of angles of cyclic quad. So I did discuss this with yesterday's group, but just to say again, whenever you are trying to check whether the properties of a cyclic quad actually work for this quad, in order to prove whether it is cyclic or not, your reason is always going to be the normal reason, but then you put converse in front. Okay, if you know that it's a cyclic quad, that's what we did in number 1 and number 2. We use the fact that the opposite angles are 180. Then we just say opposite angles of cyclic quad. Okay, if they're asking us to prove if it's a cyclic quad or whether it's a cyclic quad or not, we're checking if they equal 180. All right, and then our reason, whether it's a cyclic quad or not, we always have to say converse opposite angles of cyclic quad. Okay, that reason is important. If the word converse is not there, you're not going to get the mark. Right, is that fine for number 2? Any questions? All right. Yes, Robin? If they're asking you to prove if it's a cyclic quad or not, yes. Okay, can we look at number 4? Number 4 was a bit complicated. I think I said you only have to do up until 4.4, right? Not 4.5. So there we have 4.1 and 4.2. So let me actually just show you. I've filled in all of the values now, all right? So just follow step by step what I'm doing. They're asking to determine the size of B2 and D2 in terms of X. All right, now what I did was they gave us this angle as X. Now guys, just a hint, if you don't know where to start, just start finding angles, all right? Because usually that will kind of lead you to what you're looking for. So if you're just seeing, okay, C1 is X, now I must say what B2 is and D2. But I don't actually know how to get there. All right, just look at what's given in the diagram, what kind of triangle we have, for example, and just kind of start working out angles. Okay, hopefully you will find an angle that you are supposed to find in order to get to the answer. And even if you don't get to the answers, you can still get some marks. Okay, so what I saw is that triangle ODC is an isosceles triangle because I have 2 radii, right? So if that is X, that must also be X, D3. The reason for that would be angles opposite equal sides, radii. Now, if these 2 angles are both equal to X, then I can find O2 by subtracting them both from 180, right? 180 minus X is 180 minus 2X. The reason for that would be angle sum in triangle. Now, if we have this angle, do we agree that this is an angle at the center because O is the center of the circle and it's subtended by CD, right? A line from C and from D are joining each other and they form O2. But isn't that also the case for B2, right? B2 is just at the circumference. So if O2, the angle at the center, is 180 minus 2X, B2, the angle at the circumference, is supposed to be half of that. Now, what is half of 180? 90. And then minus, what's half of 2X? X. All right, so that is how you were supposed to find 90 minus X. You actually had to work in this triangle to get the angle at the center and then use angle at center, that theorem, to get B2. Okay, now I did it in less steps than that. I just went straight to O2. I didn't actually write down that D3 is equal to X. All right, so I just said O2 is equal to 180 minus 2X, and I put my 3 reasons in my bracket. So angle, sum, and triangle. Now guys, you don't have to write the name of the triangle down, but it is sometimes useful so that you can kind of keep track of which triangle you're working in. Okay, but it's fine if you don't have it there, don't worry. You won't lose marks. And then angles opposite equal sides and radii. Okay, these 2 reasons are actually because of D3 being equal to X. Okay, so it's fine if you wrote that as 2 separate steps. If you first said D3 is equal to X, angles opposite equal sides, radii. Next line, O2 equals 180 minus 2x, angle, sum, and triangle. Okay. Therefore, B2 is 90 minus x, half of this one, because of angle at center. Any questions on finding B2? All right, I just want to show you what I then did to find D2, because that was the second half of this question. I said find B2 and D2 in terms of x. Now D2 is this angle there. Now guys, if we're looking in this bigger triangle, triangle BCD, they actually told us that this is also an isosceles triangle, right? They're showing us there that these two sides are equal. Now, if this is an isosceles triangle, then angle B2 is supposed to be this angle at D, right? Because of angles opposite equal sides. Do we see that? This is an isosceles triangle. So that angle is supposed to be those two angles together. Okay? And we already had x. So if I know that this one, 90 minus x, is supposed to be x plus another one, we can figure out what D3 should be. All right, so that's what I did there. Whoop. So I said that D2 plus D3, that's the angle at D, should be equal to 90 minus x. If you didn't want to write it as D2 plus D3, you could have just said angle BDC. Okay, that's that whole angle in the triangle. Should be equal to 90 minus x because of angles opposite equal sides. But we knew that D3 was x, right? We found that in the previous part of this question. So if I must just get D2 on its own, I have to minus x from that side. All right, this is basically D2 plus x equals 90 minus x. And then you move the x to that side, and you end up with D2 is 90 minus 2x. Okay, because guys, what is 90 minus 2x plus x? What's minus 2x plus x? That's minus x, hey? So it works because we're saying that this is D2 and we know that that is D3. And the two angles together should equal 90 minus x. Okay, so it does work if I have 90 minus 2x and x. Okay, but that was quite a difficult start to the question. And then unfortunately, these questions all kind of followed on one onto the other. So yeah, if you got stuck on the first one, it was difficult to go further from there. Usually in tests or exams, we'll say instead of just find B2 and D2, we'll say show that B2 is 90 minus x. And show that D2 is 90 minus 2x. So that even if you can't get to those expressions, you can then use them in the next questions. All right. So whenever it's a show that question, even if you can't show it, you still are going to have to use it going forward. All right. They do that specifically so that you can actually carry on if you get stuck in the first question, for example. All right. But is that fine for 4.1? All right, then 4.2, they asked you to prove that. I'll just put up the picture again quickly. Show that EC, which is this line, bisects angle BCD. So we need to show that this line cuts this angle in half. Now I already have that C1 is x. That means that I must show that C2 is also x. Now you can see that I wrote it in there because I proved it, okay? But we need to imagine that this is all we have, all right? That angle, those two angles, and that angle there. So now we need to show that C2 is also equal to x. What if I show that the whole angle C is 2x? Well, that also works. Okay, if I have 2x, the whole angle, if that is x, then that one must definitely be x as well, right? So that's kind of what I did. I again use the big triangle BCD because I have that angle and I have that angle, and then I can find the third angle, right? By saying 180 minus this, and both of them are 90 minus x. right? Then once I did that, I subtracted x because that's what C1 is, and then I got C2 from that. Does that make sense? I'll say that again. I worked in the big triangle BCD again. I know that this angle is 90 minus x, that angle is 90 minus x. So then I can find the whole angle C. 180 minus that, but C1 is x, so then I minus that as well, so that I could get C2. Okay. So there we go. I said that C2 is 180 minus, obviously now, those two angles, and then I minus C1 as well, all right, which you didn't actually have to do, right, but I minus C1 as well, and then I got C2, because they told us that C1 is X, and C2 is the other part of that angle, yes?
So when you put that on, find the line by.
Yeah, usually it is like that, but you'll see now in 4.3, we have to use a different, but if, yeah, so if it has to do with showing that a line bisects an angle, that is what you would have to do. Yeah, but when it has to do with showing that a line bisects a line, then it's different. Okay, we'll get to that now. I'm just going to write here, you actually could have just done this. C is 180 minus 90 minus x minus 90 minus x, and that is then 2x, right? So the whole of angle C is then 2x. Therefore, C1 is then equal to C2, which is then x, and then you could have made your conclusion from there. Okay, so I decided to minus C1 straight away, but you could have just found C on its own first and saw that that was 2x. If the one half is x, then the other half also has to be x. Okay. 4.4, no, 4.3. Now this was a tricky one, and I don't know if you guys would have remembered how to do it because it was relying on theorem 1, which we haven't really practiced this year. They said, prove that DF, which is that line there, is equal to FB, which is that line there. Now guys, do we remember theorem 1? Theorem 1 says a line from the center of a circle perpendicular to a chord bisects that chord. Now you can kind of, if you remembered that, I'm not sure if you did, but you can see that these two lines that they're wanting us to prove now, they're not two sides of the same triangle, all right? If they were two sides of the same triangle, we would usually try and show that the opposite angles are equal. All right, show that it's an isosceles triangle. In this case, it's two parts of a chord. Right, so do you guys see the difference? It's two parts of a chord, so it's not in a triangle. We can't show that angles opposite to these two lines are equal, all right? It's a bit difficult. So here, what we need to do is actually we need to prove that F2, that's the one that I worked with, or we could have worked with F1, all right? But my working is F2, so let's go with that. If we can prove that F2 is a 90-degree angle, then that means that OF is perpendicular to this chord, and according to theorem 1, it will then bisect the chord, it will then cut it in half, which means that DF will be equal to FB. Now, if we just look at that triangle there, F2 is an angle in that triangle, and do we have the other two angles? Yes, all right, so to get F2, we're just going to say 180 minus x minus 90 minus x, and we will actually get 90 degrees. All right, and once we have that that's 90, we can then say straight away, therefore, DF is equal to BF or FB, line from center perpendicular to chord. That's the reason there. Okay, so it's fine if you forgot that because we haven't actually practiced that properly this year. All right, but there we have the working. So F2 is 180 minus x minus 90 minus x, angle, sum, and triangle. Again, you don't have to write the name of the triangle. You can just say angle, sum, and triangle. The answer is 90. Therefore, OF is perpendicular to BD. So therefore, those parts are equal. Yes.
So you only need to find either F1 or F2.
Yes, because it is on a straight line. So F1 would be 90 degrees then automatically. But to find F1, you would have just used exactly the same working because it was basically the same triangle. Yeah. Okay, I'm just quickly going to put the picture back on the board so we can talk about 4.4. Then I'll put the answer up again so you can copy it down. All right, so we have all this information now. All right, I filled in that those two lines, those two parts of that line are equal. That's 90 degrees. Again, we have all those angles. Now they're asking us to show that AEOD is a cyclic quad. Now that is what I colored in pink. All right, they want us to show that that is a cyclic quad. Now again, there are multiple ways in which we could do that. All right. The one that people tend to look for first is opposite angles of a cyclic quad, but exterior angle of a cyclic quad is sometimes quicker to do. All right, so that is what I did in this case. So what I did was I looked at this this quad, and I saw that I actually have the exterior angle here. All right, I have that is 180 minus 2x. Now, what would be the opposite interior angle? First, we look for the angle next to it, and then the angle opposite to that one is A. So if I can prove that A is also 180 minus 2x, then I have that it's equal to the exterior angle, so it's a cyclic quad. All right. Now, what I want you to notice is that this is actually already a cyclic quad. All right, A, B, C, D. That is definitely a cyclic quad because the 4 points lie on the circumference of the circle. Now, do we notice that we have angle C is 2x? And in this big cyclic quad, isn't C opposite A? Right? So if C is 2x, then A is going to have to be 180 minus 2x because of this cyclic quad. All right, again, if we can see that the 4 points lie on the circumference, we can use the properties of a cyclic quad straight away because then it definitely is 1. Okay, so that's what I did. I said that A is 180 minus 2x, opposite angles of this cyclic quad. Therefore, O2 is equal to A, and O2 is the exterior angle of this pink quad. And if it's equal to the opposite interior angle, that will make it a cyclic quad. Right? Does that make sense? If you didn't realize or if you didn't recognize the exterior angle, you could have found that O1 is 2x because of angles on a straight line, right? If that's 180 minus 2x, that one would have to be 2x. And then if that is 180 minus 2x, then they would add up to 180 degrees because of converse opposite angles. Okay, but it would be more steps. So there, that's what I did. I said A is 180 minus 2x, opposite angles of cyclic quad A, B, C, D. Again, you don't have to write the name there. I just do it to keep track of what I'm working with. And it was already given that O2 is 180 minus 2x. You didn't actually have to write this down. Okay, well, it wasn't actually given. We found it previously. Let me rather write that. This was from 4.1. Or you can say proven above, or you don't even have to write it at all. It's fine. We've written it before. Okay, so A is equal to O2. Therefore, AEOD is a cyclic quad, converse exterior angle of cyclic quad. So guys, the normal reason, if we know that it's a cyclic quad and we're saying that the angles are equal, we would just say exterior angle of cyclic quad. Because we are now proving that it's a cyclic quad, we have to put the word converse in front. Yes, yeah, sorry about that, guys. In some textbooks, it said that angle A was 180, which, I mean, yeah, you could tell that it can't be because it's in a triangle, it's in a quad. Yeah, it was a bit strange. So yeah, sorry, that's one of the things that I told yesterday's group to ignore. Yeah, I'm sorry, but I think it was after I stopped recording. No, you couldn't, because then you are assuming that it's a cyclic quad. Proving that it's a cyclic quad. Okay, so you have to show that 180 minus 2x through other means. Okay, not using a property of the cyclic quad. Yeah, so guys, the question is, it's fine, that's a good question, all right, and it is a mistake that's made often. So Robin is asking, could you have said that A is 180 minus 2x because of exterior angle of a cyclic quad, all right? But in this question, they're asking us to prove that it's a cyclic quad. They're not telling us that it is one. So we can't say that it will be because of exterior angle of a cyclic quad, all right? Then we're using what we're supposed to be proving, which we're not allowed to do. Okay, you get 0 for that straight away. So you have to show that A is 180 minus 2x through other ways, and then say because A is equal to the exterior angle, it is a cyclic quad. Okay. All right, guys. There was one last thing in terms of proving that a quad is cyclic that we actually haven't discussed. It is in the note, but we haven't actually written it down. We haven't looked at examples. So I just want us to go back to, I think it was the first note that we wrote on cyclic quads. All right, so it was just like a written note. It just was saying cyclic quadrilaterals. I think I wrote this with you guys, right? A quad with all 4 vertices, whether the circle is drawn or not, and then we discussed. So we wrote down 2 of the theorems, all right? So the opposite angles of a cyclic quad are supplementary, and then the converse is if the opposite angles of a quad are supplementary, then it is cyclic, all right? We've been practicing that. Same thing here, the exterior angle of a cyclic quad is equal to the opposite interior angle, and the converse is if the exterior angle of a quad is equal to the opposite interior angle, then it is a cyclic quad. That's what we did just now in that last example, or that last question. Okay, and then we went straight into those worksheets. There is actually a third way of proving that a quad is cyclic. So I don't know if you guys have space underneath, all right, or maybe you just need to write it on a new page. I'm just going to write it underneath here so that it's all on the same, in the same spot, but it's fine if you write it in a different spot. I actually think we should just write all 3 ways down, all right, so that it's more, yeah, so that it's more kind of, I don't know what the word is that I'm looking for. Never mind. All right, so 3 ways to prove that a quad is cyclic. Okay, you can do this as a new note, guys. That's probably easier. Say again? It is kind of a part of this, but let's just do them all. Yeah. So just do a new note. It's fine. Then you don't have to try and find space. 3 ways to prove that a quad is cyclic. Right, and we can draw lines underneath. Okay, so first I'm going to write down the ones that we know already. If one pair of op angles of a quad is supplementary, then the quad is cyclic. And that is where we would say converse op angles of cyclic quad. Okay, so we've practiced both of these ones already, 1 and 2, and we have the reasons there. Now the third one is new, so I'm actually also going to draw a little diagram for the third one just underneath. Sorry, 2 lines of tens. Let me just take out this 2 here. Okay, guys, that third one, right? It says that if a line subtends equal angles at two different points on the same side of the line, all right? So if we're looking at this picture, those two angles are equal. And do we agree that these 2 points are on the same side of the line? They're both above the line. Okay, so that same side just means above or below, right? They must both either be above the line or below the line. So if that happens, do we agree that this looks like an angle in same segment situation, right? Where you have this line and this line is subtending two angles that are equal. Now guys, the only way for that to happen is if this line is a chord and if these 2 points lie on the circumference of a circle or can lie on the circumference of a circle. I'm going to say that again. The only way for a line, one line, to subtend equal angles at two different points is if it's a chord subtending angles at the circumference of a circle, right? That's what angles in same segment says. A chord subtends equal angles at the circumference, right? Or if a chord subtends multiple angles at the circumference of a circle, those angles will be equal. All right. Now, if you have that, guys, if you have a line, now remember they ask you to prove that something is a cyclic quad if it's not already drawn with a circle going through the 4 points. All right. So it will be a line somewhere. If that line is subtending two angles that are equal, so say that angle is 30 and that angle is 30, or that one is x and that one is x. The only way for that to happen is if that line is a chord of a circle that's not drawn. And what is a chord? It's a line going from one point of the circumference to another point on the circumference. So if this is a chord, then these 2 points can lie on the circumference of a circle, right? That's what would make it a chord. And then if those 2 points also lie on the circumference of a circle, and if we have 4 points lying on the circumference of a circle, doesn't that make it a cyclic quad? Right? Now, what is weird about these kinds of questions is that usually that line is not drawn in. Okay, so it will literally look like this. It won't even look like a quad. So you would then actually have to either draw this line in or you would have to visualize it. Okay, so they'll probably say, let's actually give letters here. They'll say A, B, C, D, for example. All right, let's imagine that that is in a question. They'll ask, is A, B, C, D a cyclic quad? Then you might think, because now that pink line isn't drawn in, hey? Then you might think, wow, it actually can't even be a cyclic quad because it's not a quad, all right? But you have to then imagine, you have to visualize, or you can literally draw it in if you want, that line. Okay, but this is then how it will work. If you can prove that that angle is equal to that angle, or if you have it previously, all right, normally that's how it works. You've already calculated the angles, and now you must see, okay, that angle is actually equal to that angle, meaning that BC is then a chord. So B and C must be on the circumference of a circle in order to make it a chord, all right? And that those two angles have to be at the circumference as well. That's the only way for them to be equal. All right, that's why the reason is then converse angles in same segment. Okay, so it's not actually a cyclic quad property, but it's more a property of having a chord and angles on the circumference. Okay, meaning that these 4 points making up the chord and the angles lie on the circumference of a circle, whether that circle is drawn or not. Therefore, the whole shape will be a cyclic quad. Okay, so this is the most difficult one, guys. This doesn't get asked very often, all right? But it is something that you have to be aware of, that is a way of proving that it's a cyclic quad. Okay, a part of the homework was also revision exercise number 4, which we didn't mark now because I actually also forgot to do it. So I will mark that with tomorrow's group. Let me just see how much time we have left, about 7 minutes. I just want to check here quickly if there isn't a question like this, maybe. Not really, it doesn't look like. Yeah, we didn't start tangents now, but you guys have the notes. Shafa, you must just come take some notes from me just now before you go. So we'll be working on those notes in class tomorrow. Okay, so you must just watch the videos for that, or video for that. Okay, I'm just checking. Yeah, it's fine. I'm not going to give more homework. All right, so don't worry if you've already done number 4 from the revision exercise. You don't have homework for tomorrow. Otherwise, you can just finish that up and I'll mark it as tomorrow's group. Okay. Right, guys, your test is still scheduled for the 3rd of September. All right, if that changes. Friday. If it changes, we will let you know, but you must just keep an eye on the grade Google Classroom for all test announcements. It's definitely the 3rd, Robin. No, it was always the 3rd. I think so. Was it the 10th version?
It wasn't.
You were probably.
Like, Robin, really, you were asking for very long. Oh my gosh, nobody told me.
Well, I mean, I'm having it now. Yes.
Oh my gosh, I'm a cheat. Is this hard as it gets?
Yeah. Oh, as hard as it gets. Well, we are.